All right, so we're back at it with the petri dish illuminator, which is basically, let's just, I guess I do want a mouse. Let's see, do we have this thing? No, it was this one. Okay, so these are some sketches of it. These are all terrible, but let's just hop into here. We can close all this stuff about Nikon lenses and stuff like that. All right, so so this is the box. Let's see, this is the full thing. So from the top, you can see there's a PCB, and there's an opening here. And so this is going to be made out of wood. So I have some, I went to Home Depot, I bought some wood and some clamps. And then one thing that's interesting here is that, how do we get the top? Is it 7, 6, shift 7? So here there's some cutouts here for some threaded inserts into wood. And now I'm using 1/2-inch plywood, so that's kind of a gamble because you're gonna have to pre-drill into there and then use the hex. And I'm pretty sure I'm gonna split the wood. It was like 25 bucks, but it's a risk. And then the other thing we've done so far on this project is design a PCB. And the schematic for this PCB was done using a new tool called Adapile, which I would rate a 6 out of 10. And I like it. I think it's hard to be sure that what I have in my head for what the functionality is really this. And one of my biggest complaints about ECAD in general is just that um, um, oh, I have to really doesn't have auto updating on Linux. Okay, then never mind. But okay, but this is kind of cool. So it's basically it's a Python-ish language, not really, and then like everything nowadays, and which is interesting in its own right. But so you specify a schematic, but you still have to lay out the board, of course. Um, and so then it just opens you up back into KiCad's layout tool, and so this is what we came up with, and I'm pretty happy with it. I got some cool silk screen art that we did yesterday, so that's fun. Wait. Oh wait. Silk screen art that we did yesterday. So that's cool. But the problem is that we ran into is that I got this, which is called an they Nikon MC-DC2, and basically it's a special connector that they have that that plugs into the camera and allows you to use a remote to either do like a rapid fire pictures or to just take a picture. And what we learned yesterday is that the understanding of the specification for and we actually took apart this remote, and I didn't understand how it actually, because literally the only thing in here is a PCB that has one switch on it. And the thing is, there's 3 traces coming out of the switch. I don't know how the hold causes it to do what it does. Actually kind of interesting. I kind of want to like take it apart more, but we're not going to do that. Press the shutter button halfway to focus. The thing is, it doesn't even seem like there's 2 noticeable clicks on the thing. But I think that when it... Oh, they're actually... So it must be a switch that has 2 things that makes 3 contacts. Because the surprise that we learned, that is great that we learned this before we ordered the PCB, is that in order to cause it to take a picture, because we're going to manually set the focus, so we don't want this thing to focus, and is to basically tie all 3 of these contacts together. And what I was thinking of doing in a pinch is to just use a TS connector, and that will fix our problems. But what I'm going to do today is we are going to build a little breadboard circuit to basically test that if I so what I'm going to do, I'm going to plug this into the camera. Then I am going to have this. Then in here I have these adapters, because this is a 2.5 millimeter headphone jack, which is not really a standard headphone jack. So I bought these adapters. So this will allow me to go from 2.5 to 3.5. Then now I have the female side of this, right? Which is something that I need to go grab, because I didn't grab that. And then the idea there is we're going to take the female side of that, cut it in half, break out the wires. I guess we're going to have to solder some solid core wire onto that, and then we're going to break it out onto this thing. Then we're going to put a transistor in here, and let me think. The schematic for the transistor will be that the base goes to a pinout, and then all we're going to do is we're going to tie each of these 3 contacts onto the 3 lanes, but then we're going to tie the tip and ring together. Okay, so I need to go get a cable. What else do I need? I guess I'll need a lighter and some heat shrink tubing, and then okay. And then the goal today is that I actually order the PCB and then I start construction of the box. Okay, so what we're going to do is we're just going to, and let me think a little bit about this. So we can always extend this side. So, ooh, that's really tight. Okay, so one thing that we maybe want to do, it's loose from this side and tight from the other. I kind of don't like the quality of those. Okay, so why don't we just test, because at any point along these contacts this thing could break. So I'm gonna retest that I can indeed take photos with the camera. So we need to plug in the camera. This is so overkill, man. But also, we do it because it's fun. And it is fun. But building a custom PCB for this is just like kind of hilarious. All right. Okay, camera's plugged in. Now we're going to plug this into here. And we're going to plug this into the MCDC2 port. Okay, then we're going to turn on the camera. And now we're just going to see, does it work? And it works. All right. Good. So now we can indeed break this. And then one thing that I want to know is it'd be helpful if we had a male. Or maybe, you know what? I brought another. I thought I brought another cable. That's a. I thought I brought another male 1/8 inch. But I'm not seeing it. Let me go look inside. Because what we want to do is we want to check for continuity so that we know which probe is which. Because otherwise, it's going to be really hard to debug. Okay, I'm not seeing it. All right, I'll be right back. We shan't ever forget Anand's law of outdoor electronics. Inevitably, you will bring your entire laboratory outside. All right, so I got the tripod too because I'm probably gonna want to. I don't know. All right. So I have the cable. So we're gonna basically break both of these cables, so that we can do this. So we can have. So first off, let's just do a basic continuity test. So I brought both sets of probes. And I think these probes can go down there. Oh wait, we have something else in here. Okay, and then the other thing that we're going to do for the odds and ends is this is the UC E6 USB cable that I guess a lot of Japanese camera makers used as their USB connector. And what we're going to do is we're also going to test if this G Photo 2 thing will work. And I expect that to work pretty easily. Okay, so let's just open this up, turn on continuity. I think I have background noise remover plugin on, so you probably won't be able to hear this, but rest assured, I will tell you if there's. Okay, so we're gonna do tip. to tip. Okay, yep. Ring to ring. Yep. Sleeve to sleeve. Good. All right. So this all works. So now what we're going to do is cut. So how long do I want to make it? I'll make it like this long. So let's get the strippers. And you know, I'm missing my good strippers. I don't know where they went, but it's actually really annoying. Okay, we're gonna cut this. You know, sometimes I get real worried. I'm like, oh man, I'm worried about cutting stuff, but it's like, bro, this stuff is so cheap. Okay, so now this is like really big wire. So I'm just going to slice it gently. Try to get it out. There we go. Okay. Oh, you know what's actually really nice? In here is they double insulate it. I gotta be more aggressive on this thing. Okay, there we go. All right, so we have... Oh, okay, interesting. All right, so black is... Okay, so there's... Can you see that? So there's a copper strand, which is the sleeve. This is almost certainly the sleeve. I kind of wasn't expecting this, so we're gonna need to and then this is like teensy freaking wire. So the first thing I want to do, I think, is I'm gonna attach a piece of black wire to this. So let's get the soldering iron all set up. Lots to do today. And this is one of these days that's actually kind of fun because like the items are relatively small in terms of like you feel like you're making progress because you're doing lots of little things as opposed to like a big thing. You know, normally I would like set up the camera, but since we're going to be using the camera to test, I just don't care enough. All right, so the soldering iron's on. I have the heat shrink tubing here. So what we're going to do, and what we can do at the very least is just do scene, webcam. Audio's still good. Add, what is it? I think it's the V2, yeah, video for Linux 2 thing. And then add existing, this, okay, full screen. All right, so at least we have, it lists a little better. So, okay, so we're gonna add a wire to this thing. Should I make it short or long? I don't know. Okay. Okay, so what I'm gonna do, I have this heat shrink tubing. And this seems perfect. And what we're gonna do is like try to coil this thing around it. Oh, I don't have any solder. All right, I need to go get solder, and I might as well get the third arm. Okay, so, and then, the very least, we can do this. Okay, so we're just gonna hold this, these grippies, get some solder. Oh wait, actually this is okay because we have the other end of it, so we should just be able to clean it off. Okay, then the next step is where did we put this thing? Wow, that is hot. Oh wait, this is the wrong. Where did I put the heat shrink? Whatever, we can just use more. So, on here, it doesn't need to be that long. It needs to be like this long. So cut some off of there. And then we'll put this on here. And then we'll get these other wires away from this. And then we'll just... And then I'm going to turn it. Okay, and that's it. So now it should be a pretty strong contact. So now we're going to have to do that for the next of these two. And these things are like 30 gauge wire. This is like teeny. I don't know what's up with this, but I mean, like, it is teeny. Okay, so now what we need is some red wire. And we want to make it the same length. Maybe I'll cut them to length afterward. Save me the headache. All right, so we want to make it that's a little long. Okay. Try to wrap it around. Bring it around town. And this is fine. Okay. Same thing. I used to just use electrical tape, but actually, since I learned about the lighter thing is actually easier. I kind of burned it. People say the heat gun gives you a better thing, but it's like, what am I going to really bring out a heat gun? That's insanity. Okay. Last one. We got one more. So wait, one thing that we should double check though is I shouldn't have put away this thing because inevitably you end up needing a continuity tester. Okay, so what we want to check is that the sleeve actually goes to the black, which honestly, there's no way it doesn't. Wait. Nice. All right. And this was indeed 30 gauge wire. Teensy stuff. Might even be smaller than that. I can't even tell. Okay, some white wire. And I don't know if red is the tip or if white is the tip. I don't know. Well, we can figure that out. Let's just do that. And we can search it up, or we can just do the experiment, you know? All right. Red to... Oh, so red is the ring. Okay. Whoa. I'm antsy today. Okay. Okay. Oh no, there's no white in here. Let me see if I can go find some white heat shrink tubing. Okay. So, let's see, how much do we want? Do it like that. What the hell? Okay. Good enough. Okay, so now what we should be able to do is let's just test it, make sure that that operation did what we wanted it to. So now we have the tip. So wait, we can put this back. The tip. Yep. The ring, or the sleeve, and the ring. Yep. All right. So now we have a way to take the breadboard, and well, here's what we're gonna do. We're gonna have, you know, black, red, white. Okay. And now one thing that we need to do, which is our standard Oh, I didn't bring any pliers. Okay, let me go get some pliers. And we're gonna need a micro USB cable to code this thing. And then what we're gonna do is we're gonna tie white and red together. Sorry, let me get some pliers. Like, what is it? Those BC 548s or whatever? I forget what they're called. Okay. So we're done with soldering for the time being. So now we have this. This will go to will it? Oh wait, no. I'm silly. This will go to this. So what we can do is, we're gonna need the other one, which is on the remote. Wait. What am I trying to do? We don't need to do that. Okay. Okay, instead, let's just do Gemini, because I don't know why this thing is so stupid. Um, I feel like it's just broken on Firefox. All right, so in the meantime, we can. I don't think we need any more soldering, so we move this out of the way. Okay, so what I want to do. Do the standard thing that we do. Type plus to plus. And minus to minus. That's a little bit excessive, if you ask me. Shit. Oh wow, this was smarter than freaking. Um. Well, let me see if I have an optocoupler or an omega resistor. It doesn't render the ohms. That's silly. The risk of damaging your camera with a properly wired transistor circuit is extremely low. The optocoupler is recommended as the gold standard for safety because it makes it almost impossible for things to go wrong, but a transistor is perfectly acceptable. Um, I mean, I know what it... Okay. When you use the transistor, you build a bridge between the two circuits by connecting their grounds together. This is called common ground. You must agree on what 0 volts is. The TRS... I mean, we're talking about milliamps. But still, I will do it the right way, of course. If a catastrophic failure were to occur on the Pico side, it's theoretically possible for a damaging voltage to cross the ground bridge and affect the camera. Okay. So we need a 1K resistor. Um, okay, Pico into the breadboard. Transistor into the breadboard somewhere nearby. I always forget the difference between PNP and NPN. Okay, GP is to the base. Connect a jumper wire from the transistors, the emitter. Connect a jumper wire from the emitter to ground. Um, yeah, we'll use a 500 ohm resistor and we will do the LED test because I don't know if I have the right Oh, really? Oh. Okay, cool. So we're gonna do that. Um, that's fantastic. Now let me go find my transistors and I'll get some LEDs and then I'll get my resistor kit. So LEDs, resistors, and transistors. Okay, so I think it doesn't really matter which transistor type I use, as long as the what do they call it? The threshold is logic level. All right, so let's list out. Okay. I have the following transistors, which is best. Okay, the first one is this RFP 30N06LE. Then I have, actually, this is gonna be so annoying. I wonder if I can take a picture with a. Let's just do this. Then IRFZ44N 510N 510N 520N 530N 540N, and then IRF 640N 740N 840N 3205. This is IRF. And 9540N. Oh, it probably says I don't have enough. And okay. So let's duplicate this so we can go back to the Okay, so let's unplug this because we don't need this right now. BC547. Okay. So yeah, so let's go back. So first off, BC547. Wait, what's the difference? Okay. So we're gonna do the BC548, which is what I guessed. I guessed that because I remember having to use that. This is a super common transistor. It's also the one that I've used the most of, so I have the least left. We need the pinout though. What? What is this crummy data sheet? Here we go. Oops. Okay, so we have the collector. Oh, in this case, let's actually do it like this. Okay, so we have the collector. All right, now let's go back to the diagram. Or to this one. All right. So we'll need a. Did I ever get a micro USB cable? I feel like I did. So okay, so we'll do that after. All right, let's get a 1K resistor. Base is always pin 2 pretty much. Did a. Yeah. Okay, 1K. Okay, now we need RPi Pico pinout. Okay, we're gonna use. Okay, so. All right, that's fine. We're gonna do it exactly how they did it. There's no confusion. All right, 15 goes to the base. Okay. 15 is at the base. All right. The ground. Oh yeah, we need to ground this thing. Wah 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 wah. Oh, we have so many grounds. All right, so let's just use pin 3. Okay. So pin 3 up here. Oh, they actually have a little square shape to tell you that they're grounds. I never noticed that before. It's pretty interesting. Okay, so we got the ground. The emitter is going to ground. Okay. The emitter is grounded, base is connected to a GPIO, and now all we need to do is we need to tie the 3v3 out, which is 2 below the ground, and we need a red wire. Red wire, red wire. Okay, so it's 2 below this thing. 3v3. Okay, ground 3v3. All right, so this is all powered. Now we want a 500 ohm resistor because I just want to be on the safe side of this whole thing. Or maybe a 470. Well, I haven't written Pico code in a long time. It's been a while, man. Okay. Okay, so let me just get a shot. The circuit, ground, power, transistor, base, collector, emitter. And then we've tied the bottoms. Okay, so the circuit is hooked up, and now all we have to do is do a little bit of cleanup, and then we can get this thing working. Oh wait, you know what we forgot is the LED. Breadboard power rail to the resistor. Lol, forgot all about this. Okay. Then the long leg. And then the short leg goes to the collector. Okay. Okay, now we're set up. LED, resistor, LED. Okay. Now we're good. Let's go find this cable. I don't know. Oh, wait. It's in my pocket. All right. I was like, I could have sworn I brought it. It's in my pocket, bro. Okay, well, where's the code? Ugh, why did it write so much code? I think what we need to do is, do we have the, there's the Pico. There's this. But I don't remember about that. And then there's Micro Python. Micro Pico. Oh, this gets installed. Pico MCDC2 test.py. So from machine import pin. P is equal to pin 15 pin dot out. And then is that how you do it? Value. Okay. P dot value 1. All right. So we should be able to just wait, what? Permission denied. What is that thing that... Oh, wait, you know what I didn't do? I don't think I... Oh. Uh, wait, hold on. There's Ampy. Micro... Right. Ampy is for... Okay, so wait, hold on. Uh... Um... wait, okay, wait. I think what I have to do is I have to unplug this, hold down boot cell. Then we do this. Now we can do flash Pico. Oh, what a great way to do that. Oh, shoot. I wasn't even on my thing, man. Okay, well, I flashed it. I used the extension to flash it. And then can we just disable add a pile? Think clogs up the whole freaking thing. Damn it. A second too slow. Okay, so can we connect now? How do I know if it's... This is going to open in a normal Python thing. Connect is not doing anything. Well, maybe... Let's just go through the flow. I don't care. Why is this totally unresponsive at this point? No comm device found. I don't think it actually flashed my... I love this thing. They're just racing to fucking... Flash. Can we try this again? Wait, let's close all this crap. Okay. So this should disappear, right? I think I need to manually do it, right? I don't think that thing is working. Wait, did it say something? Okay, I think that's just bugged. That's okay. How do I flash? Wait. Okay, let's just go here, here. Download. It's currently in boot cell mode, I think. Yep. Oh, really? What? Log out? Oh. Wait, this is what I want to do. Oh, here we go. Oh, sick. Okay, great. We got it working. The LED is on. That was so annoying. Dude, I can't catch this guy. Usually I can catch him. I wouldn't care. It's just that this type of bug specifically loves to go into your eye, and they just kind of hover around. Worst type of bug. So annoying. Okay. What? Oh, restarted. Okay. So now we're ready to do the circuits to control this thing. And the way that that is going to work is this is going to go in here like that. But before we do that, let's get this all sorted. So we're going to have the sleeve, which is ground, the white, which is the tip, and the red, which is the ring. Okay, then we're going to tie those together. So we can switch over to this. Okay, and now what we want to do is okay. We probably do want it, right? Okay, so we don't want it. All right, so we're gonna get rid of this, and we're gonna get rid of this, and then we're just gonna get a blue wire. Okay, I think we're ready. All right, get the camera here. It's plugged in. It's on. Okay, so now what we just need to do is we need to open up that terminal. Do this again. Oh. Well, it didn't take a picture, that's for sure. Oh, you know why though? Hold on. Shit. Because we missed something really important. Okay, let's try it again. Nice. All right. We did it. So that's awesome. It works. And the thing is, just leaving that on, it just rapid fires photos, which is not what we want. So I guess. Oh, that's awesome though. That's really nice. That's a win. Oh, I was on the wrong camera. I mean, all I ran was this code. Okay, so all we need to do is go to add a pile and add one more contact, which is the all right, so we're done with the Pico. We're done with this. The only thing that we need to do now that was satisfying. It's nice to know when things work. Or it's nice when things work. All right. So now we know how it works. Code. Okay, we need to re-enable add a pile. And then in here, we need to add the ring is tied to. Oh wait, did I do that right? Okay, so before we commit this, okay, but actually no, we'll do this commit. So have not changed route layout routing. Yeah. This should be a pretty easy fix. Hypothetically. I don't know. Oh, please, for the love of God. Picking parts, one warning. Building bomb, four warnings. Probably the... Okay, we're gonna need our mouse now. I actually feel like a badass right now. You know, we just like validated that this thing is gonna work, man. We need to do the G photo thing first, but there's one unrouted connection, and that's gonna be here. This is the ring, and the ring just needs to go to here, right? Wait, sleeve. Hold on. Let me get my notebook because I'm not messing this up. I mean, I know it's right, but I'm not messing this up. 1 is sleeve, 3 is ring, 4 is tip. All right, so we just need to do this. Okay, sick. So now all we have to do is rebuild the... Okay, we get a weird island here on 5 volts. But that's okay. Okay. That should be it, right? All I have to do is B, and then we have to build the bomb again. Okay. Add the T to R trace and redo the fill zone and rebuild the fab the Gerbers. Okay. All right. Now let's test G Photo 2, right? Wait, can we actually look at the diff? Oh, okay. Wait, actually, wait. Can we reopen that? I want to make sure that none of the silk screen moved. Okay. I'm glad I got that cable yesterday because that would have been a nightmare. All right, let's run this. I hate running this because I have so many stupid PPAs. Okay, let's get the cable. Set the camera connection mode. Oh, baby. Nice. Oh, baby. That's very easy to do, isn't it? Isn't it? That's very easy to do. Awesome. So that should just work. That's really easy. Um, so I think it's time now. So we can turn off the camera. All right. So we did the two main tests. I have validated that this device will probably work. So I think it's time for me to um I might go inside and go order this PCB. because we did it, right? Like we tested. The only thing that I didn't really test is I didn't use a MOSFET to drive some LEDs like this to check all the currents. But with that VCC power plane and then the dual via stitching and then the ground plane on the back, with two vias like that, I feel like I'll have no heat problems, to be honest. Damn, bro, I'm really gonna order this thing. All right, so let's see. Everything is pushed to GitHub, right? All right, so I am going to um okay. Okay, wait. Let's actually go through the flow here and um remember how this whole thing works because I've forgotten how to order these things. So, um okay, so wait. So let me write down this stuff because I really don't want to mess this up. So, okay, so order LCSC to my address. Then email support with order number to intercept. Order JLC to Sam Tai in Hong Kong. Email LCSC support with both order numbers for combination. This process is so sick. This process, bro. Okay. So, all right, I'll do a little spec out. Upload a bomb. Source, Atto, Illuminator, layouts, default, production, bomb. I think that's all we need, right? That's really the only thing. $5, man? What is MOQ? Oh, that's fine. Yeah, so SMT, so this is 10 cents each, man. This is crazy. All right, so we need to add parts, right? Let me go add. Well, I guess I'll do that after. I'll figure this out off. Oh, but we don't need some of these. We don't need to order. Maybe I'll just order more. But I wrote down yesterday. Okay. All right, so I'm gonna go inside and order this. So let's just go to JLC. The issue there is that this shoots up the. So $50 plus. I'll probably get the fast shipping this time. The thing about the fast shipping. Actually, I probably won't. I'll probably get the slow shipping. And then on the LCSC side, I'll get the fast shipping. Because the annoying thing about this process that's stupid is I have to pay 2 shippings. But so this is my setup. So can we look at this? Can we go to the Gerber viewer? Wait, it lost my thing. Black, lead free, stencil, custom size. This thing is gonna look sick. Why no 3D? Wait, I feel like the last time I had 3D. Bro, why does it keep going back to that? What are they saying? Where is this? The solder mask. Okay. Okay, so we just need to move that. Alright, so we are not done. Okay. Oh no. Uh. Okay. Oh, yeah, you have to. It's just near pads, right? Yeah, silkscreen to pad. Okay. LED 5. The annular ring width of pads compared to holes. Let me make some food. I'm getting hungry. So mine are all 0.15, right? No, mine are all. Yeah, mine are all 0.15 because it's zero point 0.3 divided by 2. So I'm fine. I'm right on the. I'm fine. I don't need to change that. if I select all my vias and then I change it. So wait, let's edit this. I'm going to edit this to be the whole is 0.3 and this is 0.7. Now we select all the things and then we change them. Did that actually change it though? We'll have to redo the. What? Wait. Ah, what? I don't even know what that one means. Okay, so B, save, more Gerbers. Oh wait, but I didn't actually do all the silk screen to pads. There's these. So I have the PCB, okay, so. All right. So let's try to re-upload, right? Can we re-upload? It is a little concerning that I don't have the 3D view. Oh, I think I just have to upload the bill of materials. Bone match. Bone file. File. Oh, hey, this position file got it right, actually. There must be some weird thing in the conversion from Easy EDA to KiCad, because they did it right. We probably do want to find all of those. Okay, so we need to go through all the vias and fix them because let's see. Okay, wait. So that's fine. That's fine. We just want to get rid of this. So we're gonna delete this. We're gonna delete this. We're gonna go here with a thick trace, and then we're gonna go V, and then we're gonna go like that. Can we grab this? Hmm. Wait, what? All right, so I think that that is just rotation bug. Same with that. Okay, so we actually went through all of the DFM stuff, which is cool. I think that that's the only VIA that is like that. But I want to actually... Can we just just delete this? How much is that going to delete? No, let's do this. Okay, so we're going to go X, V, like that. I mean, I think that that's probably stupid, but save, generate. Okay. Fix a DFM warning error about placing a via directly under a pad. What was it actually called? Okay, wait. This is the other one, right? Annular ring's good. Uh-oh. Where's the trace, though? I'm not sure about that one. Whatever. Silkscreen to pad warnings are... I didn't even... Okay, but it definitely fixed some stuff. But I'm a little upset to see that moving those things didn't actually change anything. Maybe those weren't even the issue. That was probably not even the issue. It was probably the other ones. Okay. All right, so we did the DFM stuff. All right, I'm gonna go inside and order this stuff. All right, yeah, it'll be a huge weight off my chest if I order it. I mean, I think it's good. I think it's good. I think it's good. The only thing that's kind of confusing is this whole thing, which I don't really understand. Like these four little bridges, I don't even know why we need this. I feel like we could just fill this whole thing in, but the fill zone didn't want to do it, so. But I'm pretty confident that this PCB will work. Man, look at this freaking bad boy. Oh yeah. This thing is so sick. Man, was it a process to do this, though. All right. So, all right, I'm doing it. I'm going to stop talking about doing it. I'm just going to go do it. Just double check that I pushed the latest bill of materials. I did, right? Fuck it, I'm gonna do it again. I don't even know if it... Okay. That's it. I think the bomb. Yeah, why is that being ignored? That's stupid. Why would you ignore the bomb? And then one thing that we need to do is in this and this, we are going to delete. And then we are going to actually, we're going to save this. I don't know why I hate that it like every action. All right. All right. So that's good. 200 line ignore. That's insane. All right. All right. So this PCB has now been ordered, and so is the parts. And we'll see. It's always kind of a janky process to order these PCBs with the parts because you got to like email them and then email them again. But it's done. So that's cool. I'm going to make some food now. And then we can get started on the box building, I guess. I need to look at my to-do list to see what we really need to do. I think CAD, finishing the CAD is probably the number one thing, but I really do want to start the box because I haven't done woodworking in a while and it sounds really fun. All right, I'll make some food. Bro, this is actually crazy. This is so funny. Literally, every time I'm like, dude, stuff made here hasn't made a video in a long time. And then I go look at his channel. It's always either like today or the last. This has happened the past like 2 or 3 times that he's made a video. I'm like, dude, where's the new freaking Shane video? That's crazy.
For 10 years, I have been I always get it. I go walking on the next day, do it again. Drives me absolutely crazy. I've been fantasizing for years about some kind of tool that would cleanly crack it. So I decided to make my own, thinking how it could be. Turns out, very, very hard is the answer. I was thinking this would be a pretty simple mechanism, but one thing led to another, and I basically ended up designing a mechanical computer, which of course was very hard to get working. I was thinking this would be a pretty simple mechanism, but one thing led to another, and I basically ended up designing a mechanical computer, which of course was very hard to get working. And since every failure basically meant exploding the egg when I shot it, it wasn't very fun to test. And the smell, ugh. And after all that, my wife wasn't nearly as impressed as she should have been.
It's huge. It's complicated. Ugly.
But they say you can't make them without breaking a few eggs. Or in my case, pallets of eggs. So come watch me go from youthful optimist to mature pessimist as I try to solve one of the trickiest kitchen tasks. I want this to be a handheld thing that I can actually use in a kitchen. So no electronics, no software, no 500-pound milling machine, no lasers. Handheld, compact, purely mechanical, and I think I have an idea for how I can do this. Eggshells are brittle. If you stretch them beyond a certain point, they just crack. Which reminds me of a cooking box. If you scratch it and then crack it, the cracks tend to follow the scratch. And I'm wondering if you can do the same thing with an egg. Put a scratch around it where you want it to break, and then start a crack, and hopefully split the egg in half. It's actually kind of hard to make a scratch on an egg that goes all the way back around where it started. So, I really hope this doesn't blow up my mind.
Orajel knows that oral pain keeps you from feeling like yourself.
Dude, I like this video already, man.
I really hope this doesn't blow up in my leg. That would have been a lot easier if I hadn't moved the egg in with an inch right now, but we have a decent scratch. Let's see if we can crack it. Yeah, it totally split right along the crack. And it hasn't just split in half because there's still that membrane on the inside holding it together. So to actually crack it, we have to hold it on both sides, hopefully tear it. Oh man, I crushed it. But so I didn't get crushed. Looks great. Nice clean break. I think this is really promising, and we can make a device that does this. Scratch the egg, crack it, dump the contents. Let's go make an egg cracker. I'm imagining a handheld tool that kind of looks like this. We hold the egg from both sides, kind of gripper that can spin it, and then it would have a cutting head with a little knife to scratch the egg, and then a hammer to hit that scratch and crack it. After that, the gripper can tip it down to tear the membrane and dump the egg. And we don't want egg on our fingers, so they also have to get the shell. And I want this easy to use, so all this will happen when we turn the crank. And it's the crank that makes this great. Like, how do you scribe, then hammer, dump, then eject, just by turning the crank? It's going to be bad, but we have to put it in that thought because there's a riskier problem we have to solve first, which is holding the egg. You have to hold the sloped end of an egg, which generally just will pop right out of the grip. And then there's a lot of variation in the shape and size of the eggs, and whatever I come up with has to be able to hold them all. I spent a really long time trying to figure this out. I considered everything from spikes to glues to suction cups, but I have an idea that just might work. So let's see. So this is a mold that's 3D printed. I'm using it to cast silicone around the 3D printed part, which is surprisingly easy to do. You inject the liquid rubber, wait a few hours, and then you have your part. This is called overmolding. The egg just slides in like this, and it basically forms the egg and holds it really well. And the stretchy silicones can expand to accommodate pretty much any.
Dude, I need to get good at silicone molding, man. Silicone molding is
So we
fun.
had to make a special shape within the hub that the silicone will mold around and get physically trapped so that they can't come apart. And then after the egg has been cracked, there's a built-in spring-loaded ejector that can eject the shell. That was close. And then, having too much fun. So I want to test these to make sure they work before we build anything else. I'm going to scratch and crack it by hand. Then we're going to see if we can split the membrane with these, which I think is the hardest part. So if I put the other gripper on here and twist, it should split. It's not even close. Man, that membrane is strong. I thought this was going to work for sure. I tried a bunch of different rubbers, the really soft and grippy ones to stiffer ones that'll grab the egg tighter. Nothing is working. So fundamentally, the problem seems to be that they can stretch this way, which limits how much torque they can apply to the egg. So we don't want it to stretch this way, but we want it to stretch in this direction, so it's still connected to it. And I think it should be pretty easy to do. This is the new hub for our egg gripper. It has these tethers built into it, which are really flexible in this direction, but they're really strong in this direction. They don't stretch at all. And the silicone gripper is cast around these tethers. This is a partial port, so you can kind of get a cross section on little T-shaped entities, keys in the rubber. It makes it really strong in this direction. If you try to pull on it, it doesn't stretch at all. But their flexibility still lets the rubber stretch outward, so we can get an egg in there. This holds the egg 100 times better. Here's one of the old ones. So I'm just going to manually score and fracture the eggshell and Let's see if these grippers can pull it apart. Oh gosh. Yes! I knew it! You just have to hold the egg right. We can finally hold the egg. Now we have to make everything else. And what we're going to have to do, I think, is work backwards from egg grippers to everything else, because these are sort of set in stone. It's easy to figure out the main body and crank. When you're trying to figure out how to even do something, it makes it 10 times harder to only have a tiny bit of space to do the thing in that you don't even know how to do. Every time I've ever made something handheld, I've said, I'm never doing that again. And then I do it again.
All right.
You did some of the most complicated part I think I've ever had in time. And it's for a stupid egg cracker. But I think I have something that might work. So let's get them made and find out. 3D printing is always my preference because it's so easy to do. And thankfully I've been able to use it for most of the parts. There are a few select machine parts, but they're all pretty simple. And here it is all together. Doesn't really do anything yet, but we're getting there. This is the crank that's going to drive everything, and it spins the egg through a series of drive shafts and bevel gears. And then to split the egg and dump it out, the egg grippers can pivot down like this. And there's
Don't just age graceful.
it out, the egg grippers can pivot down like this. And there's right there, parts opposite, always return, it's right there. You make the pivot, pull this forward, you wrap around, the plan is to make the mechanism that pull this at the right time. And this side, it's on the drive shaft, it's kind of a 2-point special, which I don't build back like that. And there's a pretty good detail here. The drive shaft has to be designed to rotate this way. If it rotates this way, its work will also make the egg gripper move down, which is no good. And we also have the eggshell injectors. The injectors are spring-loaded shaft that goes through the drive shaft and is held back with a little latch. It releases it. But the latch is going to release itself. You need something to trigger it to find it right. But it's tricky because they're inside this rotating gearbox, running another mechanism through this right. So I decided to make them two positions. But first, we dump the eggs, then we'll rotate even further, which is back with the basically injectors. It's even as we start to get in here. The last detail is this side slides back and forth, so we fit all the different sides of the eggs. Now that we can spin the egg, we need a thing that scratches and cracks the shell. By the is sort of floating head with a tiny nugget that can cut into it. The next step will have a spring-loaded metal rod, which we hammer on the scratch to crack it. And here's what it actually looks like. This cutting head is tiny. It was a challenge to fit all this in here, but we got it done. So this 5-axis cheating. Parts like this cutting head make me so thankful to have a 5-axis mill. It has holes and features on every side that are off-axis, and a lot of stuff is in square. 5-axis can rotate the parts to all the different orientations, which you get all in one shot. Well, except that's up. Good done with that. It's so much harder to make. It's used to pretty much all of things. Even some earbuds. This tiny little part, the end of all this cutting head, it is so tiny, and ultimately it can mount on the main drive shaft, floating on the neck like that. And this is the cutting blade. It goes in like this, so you can tune how deep it cuts and try different blades. The cutting head will contact the egg right about here. Getting the shape of this dialed in so that it could cut all different shapes of eggs was really challenging. And then this is the hammer. It's a metal rod with a rounded tip that's spring loaded. It's positioned to hit exactly on the scratch made by the cutting blade. And this spinning can lifts and drops it. The main drive shaft will go from here. As it turns, it'll spin the can this way. All of this means the hammer will always be hammering. And I'm worried that might cause issues. So I'm going to also have a little pivoting latch, which will catch the hammer and pull it back position. But if you push the latch out of the way, then the hammer is free to hammer as much as it wants to hammer. This gives us a simple way to turn the hammer on and off by pushing and pulling on the rod with some other part of the mechanism. So I'm just looking at this, and I realized I'm an idiot. Unfortunately. So I designed everything for the hand crank to be turned this way. But that'll just jam up the hammer. I even had an item in my to-do list to check that everything was turning the right direction. And I checked it off. Take the hacking. This ended up being less bad than I was expecting. I just stuck another gear in there and it reversed everything. I don't think I've ever had a literal Uno Reverso card work before. Awesome. At this point, this thing has all the hardware that it needs to crack an egg, but if I turn the handle, it'll just spin the egg forever. And that's because there's nothing in here to actually make it do all the different functions in the right order. So we basically need to program it, but we don't have a computer in it, so we have to do it mechanically. Imagine connecting our main crankshaft to another shaft with a very weird set of gears that look like this. Every rotation of the crankshaft will make this gear move through a set of distinct positions. I'm going to call this the program wheel, because we should be able to use its movement to make this thing do a series of programming steps. For example, when we start cracking an egg, we want the scrap to be pressed into it to cut a groove. We could make a shape that pushes the cutting edge.
Dude, this video is crazy,
Then when
actually.
it moves to the next position,
What the hell, man?
because the egg is also spun by the drive shaft, this would scratch the egg all the way around. This shape is called a cam, and with a bit of cleverness, we should be able to use cams to control everything. Remember that little latch to turn the hammer on and off? We can make a cam push on that to turn the hammer on after we're done scratching the egg. And after that, we can make a cam that lifts the cutting head out of the way so it doesn't get dirty when we dump out the egg. And then the trickiest part is making it pivot the egg grippers down. Both sides have a cord that if you pull on it, twists them down. So we can attach those cords to a pivoting arm that looks like this. Engineers call this kind of thing a bell crank. In this case, we can put a little wheel on the side of the bell crank, which can roll against the cam, which if we shape it right, will put the egg grippers down part way for one rotation of the crank, which will dump the egg out. And then the next rotation will rotate them further, which will trigger the eggshell ejectors. Then one more rotation and everything sets back. And putting it all together,
Wow, that device is so cool.
That pressure turns on the hammer, hit the scratch, and break. Then it lifts the cutting head so it doesn't get dirty, and dumps out the egg. And then pivots the egg grippers more to trigger the ejectors, and then resets for the next egg. Pretty crazy how much mechanical engineering it takes to replicate like 4 lines of code. It's simultaneously really complicated, but also really simple. You just turn the crank and it cracks your egg. So it's beautiful. I love it. Although it would have been a lot easier just to write 4 lines of code. But aren't you glad I didn't? So look at this thing. It's so ridiculous. I love that this can exist. But at the same time, all the incentives are not to make stuff like this. The pressure is to make things that are simpler, more mainstream, more tuned for the algorithm. And I feel this pressure, and I'm afraid of this. Because I don't want to change what I make. Like, imagine if instead of doing things that I think are cool, I was trying to do things that would perform well. Hi, what's up, team? I made a money cannon. Let's go out and pretend to help people. But the pressure is real, and sometimes I wonder if the pain that I go through.
Bro, see, Shane, Tom Seven, you know, these are the guys, man. Like, they just do it because it's
Like,
dope.
solving robot, it almost killed me. But one day I got an email informing me that I might work because they really liked my puzzle robot video, which was unexpected and amazing, and of course completely transformed my view of puzzle robot. My advice for independent media initiative, they're working with foundations to get nonprofit money, and then they do legwork to find people that are creating things that they think are authentic and artistic and wonderful, and they give them that money. They're basically creating a new set of incentives that aren't dictated by algorithms and popularity and all that kind of stuff. So thank you, IMI. I am very inspired to make more completely ridiculous things like this, and I guess we should see if it works. Here you go. You put everything together, it never works. Or as I like to call it, integration hell. The program wheel's jamming up in a road, but after micro-optimizing design, I got it working. And then in the spirit of getting everything that could possibly be wrong, the camera turned out actually being a whole jar. That can be fixed with different shape and different springs. Then we had a scrap with the big part. Then it's too low. Then we had a scrap that jumps out again. It's too sharp. Then we had to leave it in. And it was just right. Sorry, the kids are doing them for me. There's a lot of other cool problems. A lot of me making this face. But eventually we got around to it. Well, kind of. Remember how we made the egg grippers a lot stronger? They're so impressively strong that the egg grippers don't. That the egg ejectors don't work. I don't understand because I tested them when I redesigned them, but they don't work now. The reason I didn't just put a giant spring in here is that I'm extremely space constrained. So we're going to try a different approach. Because the egg grippers are airtight, if you put air in behind the egg, it pops out. I like this because it's a surprisingly easy mod. And with air power, there's basically no limit to the egg ejection force. The trickiest part is getting air to the spinning egg holders, but since they have hollow shafts, we can just make a spinning seal on the end. The next thing you know, you got loose eggs. I don't know what I did to my boy. This is a complete hack job, but it's gonna let us test the concept. We've got air lines going to both the egg grippers, and pushing this syringe in will pump air behind the eggs, releasing them.
This
But I realized
video
there's
is
something else
dope.
that's really useful. If you pull the syringe back, it vacuums the egg into the gripper. I'm not sure if we absolutely need this, but more grip is better, especially with weird shaped eggs. So let's see if this abomination works. All right, so here's how I put the egg in. Push it on one side, bring it the other side, close it, squeeze. And if we try to pull a vacuum, it'll just pull the syringe back in. So for now, I'm just holding it back with this bolt. Very user-friendly. This egg is fully cracked, but the program is going to keep hammering it for 2 more rotations, which is busting up the shell and ripping chunks off. So I'm just going to lift up the cutting head for now and see how it cracks the egg. Oh, yes! It's amazing. Although the egg spinning is back, that's going to break off shell pieces. All right, now let's see if we can eject the shells. 3, 2, 1. All right, just about. Very close. This thing can definitely work. The syringe basically did what it needs to do. Things did too, that'll be good. But I just don't like everything that's driven through there. So the egg we just cracked was scored, ready to crack, like 1 or 2 rotations. The program is just going to keep running. It's just hammering and scribing it, even though it's needed. I think we need to go through all the different steps independently. I think I see a way to do this without changing everything, but unfortunately, you're requires us to change almost everything. So I think I know what I'm going to be doing for the next week. I tried to keep as much of this the same as I could, but I ended up changing like 90% of the parts. But on the plus side, it was mostly water jetted or 3D printed parts, which are a lot easier to remake. A big part of my effort was making the air eject system easier to use and not crappy, which meant routing all the airlines internally, which was a huge pain and changed almost every part. It is finally together. It's almost like a real thing. Everything is properly designed. On some level, maybe it was worth it. I don't know, probably not. Let me show you how it works. You put the egg in just like before, then pull this back to vacuum the egg in place. And if you want to eject the egg, you press this button. But let's not get ahead of ourselves. The next thing we do is turn this knob a few times to score and crack the egg, and then instead of the program wheel, we have this little lever. And this operates all the cams, lifting up the cutting head and pivots the egg grippers, which should not do that. What? I thought we were done with this. I'll just say there are problems with the vacuum system, the egg grippers. Oh my goodness. And the shell ejection system. Now they'll probably eject this side first. They should eject this side now. There's one problem that's kind of a big deal. Do you see it? Only half of the egg is coming out. This happens when one of the shells comes off first, which leads to all the air pressure. And no air pressure, no ejection.
Oh, wow.
But I thought I'd be able to tune it out. Nope. The proper fix is too much work. I just added this valve. Now if one side fails to eject, you can close off the open side and run the injector again. Get off the check. I actually spent all day trying to make this thing that push the shells out. Check out. Vacuum. I just couldn't make it reliable. So this is what we have for now. But I'm okay with that because this is a prototype. I know if I did another iteration of it, I could fix all these things. But right now, I just want to see the process work and prove that the concept is sound. And it's looking pretty good. So let's see if this thing works.
I mean, it's just the skill of prototyping, man. Oh, it's so sick.
Beautiful. Oh man. And look how clean this break is.
Dude.
Like, almost perfect. All right, now it just has to eject the eggshells. All right, we got 3, 2, 1. Oh, it's so good. I know it's cracking an egg, but it took so long to get here. It is so cool to see it finally doing it. And it is a bit more complicated than I was expecting, but another iteration of redesigning and remaking probably every single part. We could get rid of the valve. I think we could get rid of pulling back the syringe and always eject those shells reliably. But kind of tired of redesigning and remaking stuff, so we're not going to do that right now. What I'm curious about is what my wife thinks. I suspect she's going to find it a little bit hard to use, but only way to find out. All right, light is here. She's ready to judge things. She looks like she's got a judgment face on. Does this look like the future?
It looks like the stuff of future infomercials.
Okay, let's not get ahead of ourselves. You're right. Put the egg in there. All right, pull that back. The egg is now set in place. Give this a few minutes. Feel it back.
Now how do we get the shells out?
Press this button. There goes a fine.
Try to do it again.
No, pull this back out. I'll turn this to 90 degrees. All right, press it again. Future egg cracking here. Looking past the obvious things need to be fixed.
I don't see an egg cracker.
How many out of 10 would you do this? 3? It's just people.
Do I even need to explain it?
Yes, explain.
It's huge. It's complicated.
It's great. Beautiful.
Well, my only thing is that I feel like cranking it, but it's like it's awkward to crank it. I need to play with it.
Stick it right up your sleeve and get out of here.
I ain't got no sleeve. Joke's on you.
I don't know why I even brought this lady in here. Because I don't know. I don't agree. I'd give it at least a 5. There's this kind of funny story. When me and my wife first got married, we went and got our Christmas tree, and we had the ornaments, we had the lights, and I was trying to figure out how many grand lights I could buy, we had the minimum amount, so we don't very much money. So of course I whipped out my TI-9, and with a bit of calculus, I got the lane space in that I needed, and it fit perfectly. It was just incredible. And I just love this. As a tiny little example, whipped out my TI-89, and with a bit of calculus, I got the lane and spacing that I needed. It fit perfectly, which was just incredible. And I just love this as a tiny little example of how useful knowledge can be, even for silly problems. But if you're trying to learn this stuff, a longer story, that could be really challenging, which is why I think this video sponsor is important. It's called Brilliant, and it solves the problem of learning really well. It does it by taking difficult subjects like programming and breaking them down into a series of small lessons, which aren't too bad to do, but they build one on top of the other. And if you do them, at some point, you program. It's crazy. But the secret sauce is calculus work interactive and built around solving actual problems, like writing code, solving equations, reading the binding journey. Imagine the difference between reading about building a house and actually building a house.
All right, so okay. Um Okay. I know that a lot of this stream was just nothing, but I have to end the stream. I gotta. What the fuck? A bug is in my eye. A bug literally went in my eye.